Today I'm going to show you how to create your very first MUI app on a next-gen Amiga like this one. We're going to keep things very simple, just a basic window with a hello message in it. Yes, incredibly basic, but it's also the first step towards being able to build sleek and functional GUIs on AmigaOS using the Magic User Interface toolkit. So let's get started. So MUI is what's known as a retain mode GUI. It sounds complicated, but it's just a fancy way of saying you build the GUI objects ahead of time. So you build the window, the gadgets in it, and all that sort of stuff ahead of time. And then you go into the event loop where you wait for events and process it. And the events are things such as mouse clicks, keyboard, key presses, and whatnot. So you can see that in the code here. You start the main here, we open the libraries. After that, we call build GUI to build the window in the MUI app class. And if all of that succeeds, then we go into the main loop here. And finally, when somebody tells the app to quit, then this cleanup code is run. Now notice how this main loop is almost empty. It's literally only doing two things. One, it waits for the MUI application class to return the quit signal. So if somebody clicks on the Windows close gadget, then it will send that signal. Or it waits for somebody to push Control-C, and in both cases, it quits the app, drops into the cleanup code, closes the window, cleans everything up, and that's it. So that's because MUI's preferred method of working is to handle events by passing notifications directly between objects. One advantage of this approach is that MUI gadgets can communicate directly between each other. So for example, if you have a slider and a numeric gadget, then they can send each other messages. So when you move the slider, the numeric gadget updates automatically and vice versa. Right? And it can do this by sending notifications to each other. No need to go through the main loop, the main part of the application. Everything is done directly. Now this isn't unique to MUI though, but at least not in the Amiga world, because the reaction toolkit can do that too. And even the old AmigaOS 3 Boopsy gadgets can do it. I believe that is via the OM notify method. What is different with MUI though is how MUI sends notifications to the application itself. So MUI's ideal is to actually never return to this main loop here except for the close or the return ID quit here. And indeed that's what we have. So everything else is supposed to be implemented as MUI classes instead. So for example, you would create a child class of the MUI application class, and you would put your event handling code in there. And you might have some other MUI subclasses to handle other events. Now this makes for obviously a very small and clean main loop here. And it also improves code modularity because then everything is communicated directly to the object where it's needed. And the code for handling it is there rather than all being in the main loop here. I'm not entirely convinced that the notification messaging system is indeed truly superior than the centralized while with a big switch statement for all the different event types. So sure, the while switch statement main event loop might be big and ugly, but the code execution path is very clear. You can see how the messages come into the main loop and how they're processed. Whereas with the notifications or sending signals, you don't actually see what's happening here. You know, you call this do method and then you don't know how the code gets executed. You just know that your event processing handling code gets called in some way. Anyway, MUI is designed to use notifications and subclasses and if needed callbacks as well. So let's use it as designed. Actually, since our Hello MUI program is so basic, we don't have any notifications other than the window close events, so we do not need to subclass anything at this stage. Let's go through the code bit by bit. So first we open the libraries, and we basically only need to open the MUI master library. And when you do that, make sure you use the MUI master _name and MUI master vmin macros. So these are in the MUI SDK header files, and what using these does is it makes sure that you open MUI master library, the minimum version that supports the MUI SDK that you're using to build your software. So it just saves a bit of tears and heartache later when, if somebody else tries to run your code with an older version. This will make sure it says, sorry, you need a newer version of MUI master.library. Please update. Now, on AmigaOS 4, you also need to open MUI master library's main interface. And before I forget, notice how I have this use inline here and use base type. That's for AmigaOS 4. What this does is on AmigaOS 4, this allows me to call library functions without having to use the code like this, MUI master, and then call the function. You do not need the interface pointer. You can just call the functions directly. And what that does is this code is now portable across all AmigaOS versions and all clones, at least all of the ones that MUI supports. So all the rest of the code is not specific to AmigaOS 4 or 3 or anything. It will run on all of them. Right, the next step after opening the libraries is to build the GUI, which is in this function here. So what we do is we create, MUI new object, we create an application object, which is at the right at the core of everything. So and inside this, obviously we set its title, the author's name and all whatnot. Inside we have our main window. So create a new object here, which is of the window class. We give it a title, and inside that we create yet another new object. This one is of a group class. So the group class is kind of how we lay out gadgets. It's almost redundant, seeing as we've only got one gadget. We've got this text object here. But obviously when you have multiple gadgets, you would like to lay them out nicely and horizontally, vertically, and all nicely aligned. So that's what the group class is for. And then inside that, we have our text object, which it's just a static text display that says, hello world, I'm a MUI program. And assuming that all of that works, we end up with a pointer to the application object. And we also notice in here, we get a pointer to the window because we need to access that directly. If that all works, then we set up the GUI notifications. So this is where, as I said earlier, MUI likes to communicate events by sending notifications from one object to another. So here we've got do method, do the MUI notify method, and we tell the window object that when a window close request happens, so when it's true, send the app a MUI application return ID message with MUI v application return ID quit. So this is the bit that makes sure that when we click the Windows close gadget, a notification gets sent back to the application object to say, hey, it's time to quit, and then it will cause the program to exit the loop and drop into the cleanup code. Okay, so we've built our GUI. This code is done. If that worked, then we go into the main loop. Well, actually first, we have to open the window, because when you create the window, it doesn't automatically open because you might not want that yet. So we do that here. We just set the Windows window open attribute to true, and that opens up the window. And then we enter the main loop. So we call the application new input method, and this will, wait until we get the return ID quit signal or some other signal. And the only signal that we're checking for is Control-C. And when all of that is done, when somebody tells our app to close, then we drop into the cleanup code here. So this first tells the window to close itself. So we set the window open attribute to false. Next, we dispose of the application object. And the way MUI works is if you dispose of the application object, then all the other MUI objects inside that also get disposed of. So you do not need to free or dispose of them one by one. You just dispose of the app object. Everything else is cleaned up automatically. Then we can close the libraries and exit the program. So that's everything done. Let's compile and test this. So we'll send that over to my X1000. Oh, access denied. What the heck? Typed in the wrong password. Okay, let's test this. Congratulations, you've got your first MUI program working. The source code for this example can be downloaded from the Kia Campus by creator and higher tiers. Oh, and by the way, thank you to the Kia Campus Amiga Corner members for sponsoring this video. Thanks to you that it exists. If you are watching this and you're not part of the Key on Campus and you want the source code and or you want to support creating future videos like this, then join the campus. I'll leave a link below the video. Otherwise, next time I will add some additional gadgets, so we'll have an app that does something useful. That video should appear over here. That's it for now. I'll see you next time.